And now it's my pleasure to introduce our first speaker today. As I was eating breakfast this morning, I turned on my YouTube and dialed in Ray Weil, Soil Horizons. In 30 minutes, I learned more about soil structure than I've known in years and years. Write that down. It's on YouTube. Ray Weil, W-E-I-L. He is with the University of Maryland. He has lots of information on YouTube. He wrote the textbook on soil health that dozens of universities and colleges around the world are using. Dr. Ray Weil is going to be our first speaker today. Join me in welcoming him.
Thank you so much. All right. Hey, good morning, everybody. It's great to see so many farmers out here and young people thinking about farming, the next generation. That's important. With that introduction, I'm reminded that I almost never try to tell a farmer what to do, but I try to supply some information so their wheels start turning and they figure out how they can apply that information to their farms. Farmers often tell me, just let us know what's going on below ground, or let us know what the situation is, and we'll figure out how to work that out. We'll figure out how to design the equipment and design our systems to make it work. So I'm not going to try to tell anybody what to do, but I am going to share some of the research results that I've been working on for some time. By the way, I'm real happy to be back in Virginia. I'm a Virginia graduate from Virginia Tech. I should probably not tell you how far back, but some of you know Mark Alley. He came about the time that I was a grad student. Don Sparks was there. Dave Brandt was there. Some of you may have gone to Virginia Tech as a student, studied soils under Lee Daniels. Anybody here take a soils class with Lee Daniels? A bunch of people? Yeah. Well, Lee was my student when I was a graduate TA. So that's how long I've been at this. So, and I want you to recognize that everybody here is really a special, outstanding farmer. You know, I think if you were just sort of an average, typical farmer, you probably wouldn't be here. You'd probably just be relaxing or maybe spending the winter down in Florida or whatever. And, you know, talking to your friends, you get the feeling that everybody's doing no-till and cover crops and regenerative agriculture and trying new things all the time. But actually, you guys are pretty special. When you go around the world and even around the state, you see a lot of plowed soils and a lot of bare fields. And what you're doing is really pretty advanced and out there and at the leading edge. I had the privilege of spending 3 weeks in Ukraine this summer, traveled all over Ukraine, working with the farmers there. They have some of the best soils in the world, a little bit like Iowa, South Dakota, North Dakota, that kind, you know. They make our soils look pretty pale. But this is what I saw everywhere. You know, plowed up fields, wind erosion, water erosion, tillage erosion, bare, hungry, naked soils. And I was trying to spread the message and some ideas of how they could maybe do less tillage and use more cover crops and change some of the things they were doing. So, and that's actually more typical in the world. So you guys are leaders, and we got a ways to go in the world. I'm going to focus today on cover crops. And cover crops are something that feels fairly new, but actually they've been around and recommended by the USDA and by extension back in the 20s and 30s. I grew my first cover crop. I was a farm after I got my master's at Purdue. I worked for a while as a farm manager down in North Carolina and grew my first cover crops back in 1970. My goodness, it was the early 70s. And people thought I was nuts. I remember in winter, I had the only hills that were green. Everybody else's were just brown and washing away or covered with snow. So cover crops have been around a while, but they've they're getting a resurgence because they really fit in with no-till and some of the other things we're doing. They're an important tool. They're really a kind of the tip of the spear in trying to be regenerative in our agriculture. Now, unfortunately, this is typical of what you see in a lot of places across the U.S., including parts of Virginia. This is in Indiana, sort of a bare field in the winter, pictures taken in February. I was speaking up near Purdue University, and I flew into Indianapolis, so it's about an hour and a half drive up the interstate. And I was with a couple of graduate students, picked me up, and we were looking for cover crop fields. And I think of the hundreds of fields we passed, we might have seen 4 or 5 that had cover crops in them. And this was just a few years ago. So farmers, of course, are paying 12 months of the year for the rent or the mortgage on the land. And the sun is shining and the bugs are in there and the microbes are down there for 12 months. But most farmers, with their soybeans or the corn or the annual crops, are only using that land, only taking advantage of the resources for just a couple of months. Really, it's just June, July, and August. You plant sometime in May, but by the time you start getting roots in the ground and leaves out there to capture the sun, it's already June. Looks pretty good in July and August, but you get into late August and September, and those plants are starting to senesce, and when that happens, the roots are dying. So what's going on below ground is everything's closing down. And then you got the rest of the year after harvest, sometimes more than half the year, in which if you're not using cover crops and growing something, you're not getting any benefit. You're not capturing all those resources. You're not keeping the biology fed. So it's real important that we're able to go in there and use all 12 months. The other thing that cover crops do is they sort of, I think of it as liberating the farmer from the marketplace in terms of what he can grow. If you think about what can you drive a 20-ton truck into town and sell, there are not too many things that you're going to find a buyer for. So you're pretty limited as what crops you're growing. And diversity, biodiversity, is what makes the soil work, what makes the whole system work. But with cover crops, you're not trying to sell them. So now you can go wild. You can plant all sorts of things. And I know some of you are using cover crops that are, plants that you've never heard of before, and now you're seeing what they look like. So we've got some that fit in the cool part of the year. We've got the main families, of course, of the grasses, the legumes, and the brassicas, and forbs, and other broadleaves. And then we got some that you can grow in the warm part of the year. So depending on when your window is, there's a lot of things you can do with cover crops any time of the year, and you can mix it up with cocktails and have 3, 4 species, 5, 10. Some people go even more than that, like in these pictures. And we got to be serious about our cover crops. Now, in the beginning, some people, when they start trying a cover crop, well, they'll throw a little rye out after harvest if they can get around to it and see what happens. And it's probably not going to do much good if you're not planning for it. You really, can't expect to get a whole lot out if you don't put a whole lot of thought into it. So you want to plan for your cover crops like you do for your regular crops. First, you got to decide what is it you want the cover crop to do for you. Build soil health. You want to suppress weeds. You want to fix nitrogen, to reduce your fertilizer bill, recycle nutrients. Cover crops have a whole series of things that they can do. They can conserve water. So you figure out what you need, 2 or 3 or 4 of those things, so that you can get a return on investment, so that what you put into the cover crop is going to pay back. And once you figure out what you want it to do, then you have to figure out when can you put them in, given your system. And don't just think about the planting windows that exist, but what's the potential planting windows? Now, how could you jigger your system a little bit, maybe use earlier varieties or change your rotation a little bit to open up some new planting windows where you can do a lot more cover cropping. So when you figure that out, then you can make a rational decision of what species you want to mix together and how you want to establish them. That's important, is how you establish it, when you establish it. You get a completely different cover crop depending on how you do that. How you're going to terminate it, how you're going to manage the cover crop, and then, of course, get that planter set up so it's going to do a good job in the kind of residue and soil surface that you're creating. So I've seen a lot of people just fail and say, well, I'm not going to ever do that again, because they're using their planter as if they didn't have a cover crop, and they're going into a heavy cover crop residue. So what I'm saying is that we can change our thinking a little bit. Usually we're thinking about, how can we manage our soils to improve our crops and our plants? And what I'm suggesting is we also want to think about how can we manage plants. They're a tool to improve our soils. So the best thing you can do for the soils is to grow plants. Now, there are a lot of ways that cover crops can improve the soil, and you want to think about some of these things. They can do a terrific job of aggregation and physically just change the nature of your soil. Those of you that have gotten into planting green and know how that planter runs through those with those live roots in there, and you just go out with a shovel and dig up some of your land after some cover crops and no-till, know how that physically changes the soil with aggregation and how it saves water, especially with the kind of erratic rainfall that we get. There's also the microbial aspects, which you can't see so well, but these cover crops and the plants, basically, you can think of a plant as kind of a connection, a funnel that takes solar energy and funnels it down into the soil where it's dark, and that's the energy that's supporting all the life down there. But today I want to focus on how cover crops affect our nutrient availability and how they might be able to save you money on fertilizers and help your crop plants get the nutrients that they need, both by enhancing availability and also reducing losses, which is an important aspect because some of those nutrients like nitrogen and phosphorus, if we lose them from our farm, you know that they really cause havoc in waterways, especially in the Chesapeake Bay. And a lot of people here, including the organizers, are very interested in what happens in the Chesapeake Bay. So just to review quickly, I think probably most of you know a lot of this, but how does a cover crop improve the nutrient situation in the soil? Now, if you're growing legumes, of course, they'll fix nitrogen. They're taking gaseous nitrogen, it's most of the atmosphere, and turning into something that plants can use. And that's basically what a fertilizer plant does too, to make fertilizer. But all the other nutrients, the cover crop's not going to be adding nutrients, but it's going to be moving them around and changing their availability and preventing their loss. So a big thing that they do is this nutrient pumping. Cover crops are particularly good, better than most of our summer crops, most of our cash crops. They're getting down deep and pulling nutrients up that might be 4, 5, 6, 7 feet deep. We've done some deep research and pulling those nutrients up to where your crop next year can get them, up near the surface, and substantial amounts. But cover crops will also increase the availability of the nutrients. So it's not just moving them around, but different species will exude compounds that can, for instance, dissolve some of that large amount of phosphorus that you have in the soil that's bound with the iron oxides or that's part of the organic matter and make it more available to plants, to other plants. So when the cover crops take these nutrients up, it's part of their tissue, that decomposes, and you now have basically an organic fertilizer going on. So there's a lot of different things happening in the soil. When you start no-tilling and you start having that pumping going on with cover crops, this tends to stratify the nutrients, especially those that don't move very much in the soil. So this is some data from the eastern shore of Maryland. The results from a long-term, so the red line is without a cover crop, but just long-term no-till. And you can see the phosphorus is really concentrated near the surface. Now this is soil test phosphorus, so it's the easily soluble phosphorus. The blue line is 3 years of the same rotation. It was a corn-soybean rotation, but having a rye cover crop in it. It might have edged it over a little bit. And then the green, those are 3 different brassicas. There was turnips and radish, and oilseed radish, I think, was one of them, and the rapeseed. And the radishes exude organic acids that remove the phosphorus from what's binding them and make it more available. And you can see that they really increase that phosphorus soil test. So that's good for your crop. Now this soil is already pretty high in phosphorus. Now you might say that putting all that phosphorus near the surface might end up meaning you might lose more. That's where it interacts with the rain and when you get runoff. But we actually find that that doesn't tend to happen when you have the cover crops because of the reduction in runoff, and we don't see more phosphorus in the loss. So I just want to go back to this one a little bit. Notice that increase from the green lines from the brassicas, this is in inches. So we sampled at different depths. You can see all the way down to about a foot deep, so pretty deep into the soil, the cover crop was increasing the solubility of the phosphorus. But before I get into those nutrients, let me tell you a little story about sort of my journey with nitrogen. Nitrogen is really why cover crops are supported in Maryland and in the Chesapeake Bay part of Virginia. So Maryland, quite a while ago, decided that they needed to do something to keep nitrogen out of the bay. We knew in the 1980s that the bay was dying. It's just everything in it was dying. You remember when they banned rockfish fishing? Even the crabs were getting, and the oysters pretty much disappeared. And that was mostly due to too much nutrients, causing algal blooms. And that decomposes and uses up the oxygen in the water in summer, and you just have a mess. And the bay is particularly sensitive to nitrogen. Now, if you look at, there's different ways you could keep nitrogen out of the bay. It doesn't all come from farms, about half of it does, but a lot of it's coming from cities and sewage and things like that. But they've priced it out, and they figured that supporting farmers to use cover crops, because they had done some research in the 1990s, late 80s and 90s, that really showed that if they had a cover crop every winter, it took a few years, but the nitrate really disappeared from the groundwater. That nitrate leaching, washing through to the groundwater and then into the rivers, really was brought down just by having a cover crop in there. And it was a whole lot cheaper to do that per pound of nitrogen. Now, how much does it cost to keep a pound of nitrogen out of the Chesapeake Bay? Back when they did this study in the early 2000s, doing this by improving the sewage treatment plant was going to cost you $50, $60 per pound. Doing urban sort of rain catchments to catch some of that urban runoff was going to cost you hundreds of dollars per pound of nitrogen saved. Cover crops, $3 or $4. So you can see why policymakers said, maybe this is a good place to put our money. And so they started the cover crop program. Virginia now has a similar program with NRCS, where you can get paid enough to make it worth your while to plant cover crops. And I know that's not why most of you are planting cover crops, but that may be what got you started. So anyway, nitrogen's important. So back around, this was around 2010 when I took this picture, I believe. I had been doing some nitrogen rate cover crop research on a USDA research farm that was actually one of the fields on their dairy farm near Beltsville. And so they were growing silage corn, and there was a pretty long history of manure on these farms. And I was working in Africa that year, and I came back. My grad student says, you got to come out and look at this field. We had this nitrogen rates on there, and then they planted it to barley, which they were going to use for green chop, and both the cover crop and green chop on the farm. And he said, you can see all of our plots in the barley. And this picture was taken in December, and you see all those green stripes, those dark green stripes? The only reason you see those is, and I was puzzled, what is that? I measured them. The center to center, they were 5 feet apart. Well, it turns out that the farmer was, when he was side dressing corn, instead of putting the side dressing in the middle of every row, he was doing every second row. So corn had nitrogen on one side or the other. So that put it far enough apart that you could see these like a tracer. You could see these rows. But there's something wrong with that picture. This is in December, and that was nitrogen put on corn, and the corn gave a good yield. And when you measure that, measured the barley growing in the dark strips and the light strips, and more than half of the nitrogen was taken up by the cover crop in December. That tells you how inefficient that banding, that side dressing was on the corn. If the cover crop hadn't been there, that nitrogen would all be on its way to the Chesapeake Bay. Well, when I saw that, I started looking around that winter, and there were, it's not real common, but I started seeing this in other fields where farmers had done this every second row. So there was a field on the eastern shore with all these green stripes running through it. That was a rye cover crop. And then this one was some of my own, this was a radish cover crop where I was comparing no cover and radish in strips. And you can kind of see the radish just did this. And when you measured the nitrogen in the high radish rows, it was almost all the fertilizer was still there. It had gone into the radish, in November, when it was put on the corn in June. So corn has a real problem. I think some of that has to do with the modern corn varieties that have roots that shoot down deep. And they're going down and they don't pick up that nitrogen very well that's up near the surface. So we measured that difference, and we figured that if there's all this nitrogen in the cover crop, we ought to see that nitrogen missing in the soil, right? So when we compared what was in the cover crop, that's what this graph is. On the graph, you can see the mineral nitrogen, that's the ammonia and the nitrate that plants take up. On the vertical axis is what was in the soil in kilograms per hectare. It's about the same as pounds per acre. And then on the horizontal axis is what we found in the plant. And we found about 155 kilograms of nitrogen in the cover crop, but only about 40 kilograms missing from the soil. And we went down to more than 3 feet, went down to a meter. Now there's a couple of reasons why that might happen. Maybe there was new nitrate coming, formed during that period, and there is nitrate forming from the organic matter. But we also thought, well, maybe the cover crop was actually getting the nitrate deeper than 3 feet. And that's why there was more nitrogen there. So we started looking deep. And I had a project that nearly killed the poor graduate student. Sarah Hirsch is an extension agent now on the Eastern Shore. Some of you may have run into her. But she did this work, and we tried using a Giddings probe, but you can't go down 7 feet in our soils with a Giddings hydraulic probe. It starts to bend and break the system. So we had to use a drop hammer type system. So it was a lot of work. And we did this on farms all over the region, up in Pennsylvania and Delaware and Maryland. And we did not do it down in Virginia. And lo and behold, we found a lot of nitrogen left on the table at the end of the growing season, not in a drought year, but just in a normal year with good production of crops. On average, 250 to 300 pounds per acre of ammonia and nitrate in the profile left on the table. And about half of that was deeper than 3 feet deep. And if it's already 3 feet deep on September 1st, it's not going to survive the winter in that soil. It's going to get lost and go down to the groundwater and end up in the bay. So we wondered, can cover crops go down and clean that profile up and get that deep nitrogen in time to prevent it from being lost? And after a lot of hard work, the answer is yes, if you manage the cover crop right. To find this out for sure, we used a tracer, N15. It's a non-radioactive isotope, naturally occurring. And we put potassium nitrate with this N15. It's a heavier form of nitrogen. It's got an extra neutron in the atom. And if you have a very sensitive machine, it can separate that out. So we put that down at 2 feet, 4 feet, 6 feet deep in holes, then fill the hole back up with clay so nothing could go down that hole, and then planted the cover crop over it. So we put that out end of August, early September, when the corn's finished taking up nitrogen, and there's nitrogen down there, and then planted the cover crop over it. And you can see that if we planted it early, the early planted cover crops, We're drilled in around the 1st of September. We picked up a lot of nitrogen from 60 centimeters, that's 2 feet, a fair amount from 4 feet, and we even picked up some from 6 feet deep. And this was in the cover crop by the end of October, early, certainly by Thanksgiving, I think is when we measured it. If we waited just a few weeks to plant the cover crop, we couldn't get anything from the real deep stuff and hardly got anything from the shallow. Made a big difference. So we started thinking about cover crops a little differently. And this carries out throughout the winter. So for the nitrogen capture function, this is keeping this soluble nitrogen from leaving your farm and just causing problems in the water and problems to your wallet because you paid for that nitrogen when you put it in. All winter long, you kind of think that little cover crop is out there, soaking up the nitrogen. It's not doing. It's pretty dormant out there. The action has to take place before the winter sets in, because during the winter there's very little evaporation. You get rain, you get snow and snow melt like we have right now. All that water is moving through the profile. If there's soluble nitrogen in that profile, it's going to dissolve it and carry it away. But if the cover crop cleaned it up, that water is going to move through and it's not going to pick up any nitrogen. So this is data from February. So this would be this time of year. And these are different planting dates where the cover crop was planted. And you can see when we got it planted early, 15th of August. So these dates could be a little bit more lenient, maybe a week or so later down here. 1st of September, 15th of September. That water was coming out clean. Very little nitrogen in it. But then you start losing growing degree days. The roots can't get down there. By October, end of September, there wasn't any significant difference between the winter weeds and the cover crop. So we really need to get it early. We see this over and over again. Here's another example from a completely different place. Again, this is in May, so even later in the season. And those are cover crop planting dates, 12th of September, 22nd, 3rd of October, 17th of October. You can see the nitrogen concentration in that leaching water. This is water that's 3 feet deep and on its way to the groundwater. It just goes up as you plant the cover crop later. So if you want to capture nitrogen, keep it on the farm, keep it out of the water, you've got to plant early. And that's why the cover crop programs give you extra money for getting the cover crop out early. Okay. That's a picture, by the way, of one of the students pumping up that water from 3 feet deep to sample what's leaching. Okay. So we did quite a bit of work on this. And you can see this is cumulative nitrogen loss as nitrate from all winter long, January, February, all the way through to planting in May. The black line is with no cover crop. In this case, this was a fairly high nitrogen field had manure history on it, and you can see they're losing 100, 115 pounds of nitrogen. How much is that worth? Depends on the year, but that's close to $100 worth of nitrogen just causing trouble and getting lost. Those lines down below where we hardly lost anything, those are all planted early. And then notice there's a big jump between middle of September and end of September. You start getting into October and that nitrogen's already down there. You're not going to clean it up and it's going to be lost all winter long. So the question is, how can you get the cover crop in early enough? Because I'm talking about usually it's before you're harvested your summer crop. Now, if you're growing silage corn, you may get that off early enough. That gives you a nice window. You can try early varieties on some of your fields. That may make you more money in some years. You don't know when that drought's going to hit and how that's going to work with tasseling. So it's a pretty good idea, just as a strategy, to have a range, and where you're using the early variety, you can get it planted early. But you can also interplant. In other words, don't wait until harvest. That means, of course, well, it is possible to drill. So how many of you have interplanted with a drill? Not broadcast. You're thinking, Wait, how do I do that? Well, you don't do it at the end of the season. You can do that at the beginning of the season with a drill that skips a row where the corn row is. So you take one of them off. So you're doing it in June when the corn's about a foot high. You can go and plant your cover crop then, and it sort of struggles under the corn for a few months, but it's already got a head start. The field there is on the eastern shore. That was planted by airplane before September 15th. We also have some ground-based high-boy equipment that can, sprayers that you can put a seeder on the back, so the red thing on there is a Gandy seeder. So there's a number of different options for trying to get cover crops in that early. So if capturing nitrogen is what you're trying to do, you've got to get it in early. So this is some results that we did on farms with airplanes at full field scale. So we flew the seed on half of a field, and the farmer drilled it after harvest on the other half. And this was real life, so sometimes there was a big difference in timing, depending on the weather. We did this for 3 years on about a dozen different farms. When it was really dry, there's not too much difference because the seed doesn't germinate for a long time, and harvest is early, and you can get in there and drill, and everything works good. When it's wet, it's hard to get harvest done, and it's hard to get in there to drill, so that gets delayed. But your broadcast seed that you put on early, that germinated. So that's when you get the big difference. So here you can see the white bars with no cover crop in the middle. The green bar is the nitrogen lost when you drilled as soon as you harvested, but that was a wet year, so that was a bit late. And then where we flew the seed on, that was low in all the years. So if nitrogen capture is what you're trying to do, earliness is really critical. You can get a beautiful looking cover crop in spring, but by then the nitrogen's gone. Okay, now that may not be what you want to do. The other thing that timing does is it changes the kind of cover crop you get. So one of the fun things I get to do, well, you guys are doing it too. One of the fun things about cover crops is there's just an infinite number of different combinations of things you can try out. I'm sure every winter you think of some new ideas you can try with cover crops. In this case, I was trying to see which species would grow best under the canopy, and I had these 12 species, 4 legumes, 4 brassicas, and 4 grasses. And we actually seeded this in early July. Why wait until September when you can drive over the corn when it's just tasseling? There's no penalty for putting the seed out early. And it increases your chances of there being a rain that's going to germinate it. If you wait to the last minute in September and it's a dry September, it may not germinate until after harvest. So it sat there, it was dry, it sat there for about 3 weeks, nothing happened, it was dry. And then it rained a little bit and it took off. And by August, it looked like on the left, and then by September, early September, we had a pretty darn good cover under there. And then after harvest, we had a beautiful cover, and it was able to go down and clean that nitrogen up. But it also, if you look at the graph on the right, it also changed the cover crop that we got. So the graph on the right shows the biomass in spring of the different species. The reds and yellows are the grasses, the greens are the legumes, and the blues are the brassicas. And notice that if you drilled right after harvest, that's the first bar. First of all, you got a lot less biomass in spring, in May, and mostly grass and not much legume and almost no brassica. If you put that seed on early, you got a lot of brassicas, a whole bunch of legumes, and not so much grass. So it's completely changed what you get. Now, they all did a pretty good job of suppressing weeds. So timing, choosing what seed you plant is one thing, but when you plant it makes a real big difference as well. And it all has to do with when we have growing degree days. And, in September, October, we have some pretty good growing weather, but it disappears pretty quickly. So you get into October, it gets cool enough that you're not getting much growth. And the growing degree day graph kind of levels off. And you put the seed in the ground, that's not when it starts to grow, right? It's going to take a week to germinate and get going. So you're quickly running out of growing degree days. So if you're planting late, it may survive and you'll get a cover crop in spring, but it's not going to do much in the fall. Should go back here again, and you have a similar situation in spring where it starts warming up. And if you kill it early, you're going to lose most of your opportunity for that cover crop to do its job. If you just wait a few weeks, say kill it at the end of April instead of at the beginning of April, you can get 2 or 3 times as much biomass produced because that, that growing degree day curve shoots up. Just some pictures from this fall. This was broadcast interseeded 3-way mix. I kind of like this mix. Put a few pounds of radish in it, about a bushel of rye, and 15 or 20 pounds of crimson clover. The first picture down at the bottom is just the seed. On September 14th, that's 2 days after they spread the seed. The seed's just sitting there. It hadn't rained on it yet. But we spread the seed into corn about a week earlier, and it had already germinated. So by September 28th, we already had seedlings coming up. And one thing I'm sure you've noticed about cover crops, they don't look like much in the fall when you go dig up cover crop up in October. But you start digging with a shovel carefully, and there's a whole lot more below ground than there is above ground at that point. So those roots are really moving on down. By October 25th, that 1 week delay in interseeding in the soybeans, they never caught up. Timing is really important. And then in spring, we want to clean that deep nitrogen out, because if nitrogen's 2, 3, 4 feet deep in September, it's not going to be available to your crop next spring. It's going to get lost. But on the other hand, we don't want to clean the topsoil out of nitrogen. We want, when planting time, when you put that corn seed in the ground, you want there to be some nitrate there so that corn can take off and has something to feed it. So if you plant the wrong cover crop, it uses up all the nitrogen and not only cleans up the profile, but keeps the surface, then you've got a problem. So ideally, you'd like to have high nitrogen at the surface in May and low nitrogen down deep. And that's what we're sometimes able to achieve. This was using pure radish versus no cover crop. And you can see that the red line with no cover crop, there was a lot of nitrogen. Each of these layers is in pounds per acre. So you start adding that up, you got 50, 60 pounds of nitrogen in that no cover crop. That's pretty deep, too deep for your corn will probably never catch it. So this is in May. And it's pretty low near the surface. So the nitrates all washed down. The radish, on the other hand, cleaned up the nitrogen deep, but it released a lot of it because it winter killed, and the radish just spills its nutrients out, maybe a little too early. It's good to grow something else with it to catch that up. But it was a higher nitrogen soil environment at the surface when you needed it there. And if we look, we did an experiment with farms all over, 11 different farms in Maryland and Pennsylvania, and this is the average. The black line is with no cover crop, so we had a lot of nitrogen throughout the profile, but a fair amount near the surface. The green line is with cereals, so mostly rye or triticale or barley. And that cleans it up all right, but it also keeps it pretty low near the surface. So any of you that have planted corn into a rye cover crop know that there's a problem there with nitrogen, right? If you do a mixture, even with brassicas or legumes in there, we usually don't have that problem. We can avoid that immobilization problem. So, so you can see the no cover in the mixture, we don't have that immobilization that we get from the cereals. Some years the radish will give you a real nitrogen boost. This is one of those years. You can see this corn. I think I got those pictures scaled just about the right. size person there. There was a huge difference, and that was the difference between planting into a rye cover crop versus planting into radish. And then the three that were in the middle were either no cover crop or mixtures. So in spring, there's a lot that we can do to improve the return on investment to cover crops. And one thing that farmers are picking up more and more lately is what we call planting green. This is something that farmers invented. Some of them figured it out accidentally. But it turns out that planting into a living cover crop that isn't matted down is actually, planter works better. Usually, things go better. You don't get a lot of J curving, and it's just easier to close the seed furrow, et cetera. So rather than kill the cover crop when it's small and let it get all brown and die and crisp, which is traditional recommended thing to do, you can plant on time and get a whole lot more cover crop growth by planting green. But of course, you have to adjust your planter to deal with that condition. Now you're building up, when you grow that big cover crop, that's a new plant in your system. That's building organic matter. It's putting more carbon, and when you put carbon in, you can hold more nitrogen. You have to have both together to build organic matter. Do you ever get that nitrogen back? Because if you're growing non-legumes that aren't pulling nitrogen in, you know that you don't see a return very quickly. Now, there are not many studies around that have looked at this long enough. This was one that was done way back. The study was done in the 90s. It was published in 2000, and this is in Washington, but it shows it pretty nicely. This is showing the relative yield, and 1 is without a cover crop. So if it's above 1, it did better than no cover crop, and if it's below 1, it did worse. And you can see in the beginning, if you're growing rye or ryegrass, it was always worse for the first 4 or 5 years. But that slope is going up, so after 6 or 7 years, you start to get that nitrogen back. You can build up enough nitrogen so that new organic matter is decomposing, and on balance, you end up not having that nitrogen drag problem. So you have to take some patience there. In the beginning, you might have to add some additional nitrogen. Generally, if you can let the cover crop grow a little bit longer between early, mid, and late termination, for this experiment, this was early was like first week of April, mid was around the 30th of April or 1st of May, and then late was a couple of weeks later, actually terminating a few weeks after planting. So the mid was planted green. The green line going up is the biomass of the shoots of the mixture with the radish and the clover. And the rye, and then the pure rye didn't increase very much after it started flowering. So it grew taller but didn't get any more biomass. What we're interested in doing then is figuring out what's happening below ground. It's real easy to measure the biomass of cover crops. You can see that above ground. But what's happening below ground? The roots are a really important part of the cover crop. So it's a whole lot more work to study roots than it is to study shoots. I can tell you that. It's a lot more work. There are different ways of doing it. Somehow you have to dig the roots up, you have to wash them, run them through sieves, and figure out how many you got. But we've done this for a number of years. This is some data from this past spring. The first graph is showing the shoot to root ratio. So early on, it's just a little bit above 1-to-1, which means there's almost as much below ground as there is above ground. Now keep in mind, the above ground part of that ratio is the whole plant, which you can harvest. The below ground is only a portion of the roots, right? You're only getting a certain volume of soil. The whole root system is pretty much impossible to try to capture. But we can see that the root growth is actually going down when the shoot growth is going up. So as the plant matures, it sends less resources to the roots. And so as we let this grow longer, we're actually getting, there's less roots growing down there. Right. So the roots are actually pretty important part of the nutrient cycling story. And we don't see much data on root nutrient content. So I thought you might be interested in this. What we find is that the roots are really high in the micronutrient metals, manganese, copper, zinc. So this is copper, the other one is zinc. The green is the shoots. So for instance, copper was about 5 parts per million in the shoots. And this is an average for clover and rye on 2 different soils. So it's an average on a sandy soil and a clay soil. And you can see that instead of around 5, you're more like up around 50 for copper. It's about 10 times as high. And for zinc, it's even more dramatic. It goes from around 10 or 20 up to over 100. So the roots are really concentrated in these micronutrient metals. The shoots, on the other hand, are concentrated in the macronutrients. So this is phosphorus and that's potassium. Again, the green is the shoots, the brown is the roots, so you can see it's 2 or 3 times higher in potassium. So that can tell you something about the ability of the cover crops to do the cycling and get nutrients where you want them, bringing them up in that top few inches of soil. You also want to think about the ratio of carbon to nutrients in both the shoots and the roots. So carbon-nitrogen ratio, I think you're familiar with. That pretty much predicts how quickly things decompose and whether you're going to get a release of nitrogen or it's going to get tied up, right? The dotted lines show if the ratio of carbon to nitrogen in the tissue is higher than 30, you're almost certainly going to starve your plants of nitrogen because the microorganisms are going to take nitrogen out of the soil to decompose that. If you're below 20, it's a pretty good chance that you're going to be releasing nitrogen. So the dark green line was the clover shoots, the dark brown or the sort of orangish is the clover roots, quite a bit higher carbon-nitrogen ratio. But what struck me was the rye roots way up there. I think that's part of the reason we see such bad effect of rye, even when it's fairly young rye and the shoots aren't too bad. The roots have got very high carbon-nitrogen ratio. And the carbon to nitrogen ratio is not the only ratio to think about. The same thing is true for phosphorus and for sulfur. These are part of the tissue. For phosphorus, for instance, if you're above around 200 in the carbon to phosphorus ratio, you're going to have immobilization of phosphorus. And again, the roots, as you let that cover crop grow taller, the shoots are staying low enough that the phosphorus is coming out. But the roots are getting way up there. So you might be immobilizing nutrients with the cover crop, depending on when you terminate it and what you're growing. You have some control over that without doing a whole lot of analysis, as we found that there's characteristics of different cover crop families. So you can see the individual species. These are 4 different grasses in blue. The 2 bars, the dark bar and the light bar, are 2 different soils. So you can see the completely different soils. One's very sandy soil, one's a clay soil. You can see the grasses, in this case, looking at sulfur. If you want to recycle sulfur, grasses don't do a very good job. Legumes are better, brassicas are much better. Same thing for boron. Brassicas are much higher in boron as well. So if you want nitrogen, of course, you're going to put it in legumes. If you want sulfur, if you want to cycle sulfur, bring it up from down below. Brassicas will do the job for you. For phosphorus, they're a little bit closer, but brassicas are usually higher. And this can change your soil test level. So this was the result of a single cover crop. It was that 12 species cover crop. This is the average of 2 different soils. And this is a single cover crop here, looking at the top 4 inches. And these are the elements in which the soil test was increased. So potassium, iron, manganese were not increased, but they had a pretty big increase in phosphorus and manganese and some of the micronutrients as well. So cover crops can really, especially when fertilizer prices are high and bouncing around like they've been. If you've been cover cropping, I wish we had a more certain tool to measure that. But I think your cover crop probably has put more nutrients than you know near the surface, and you can probably cut back on your phosphorus or your micronutrients for a time if the prices are high. So that's some of the information I wanted to pass on. I always want to thank the funders that have given us grants over the years, and farmers that have collaborated with us and put up with our flags and all that, students and colleagues and everything else. And so that's all I wanted to say this morning, give you some numbers to think about when you're out in the field working with your no-till and your cover crops. So thanks very much, really appreciate it. Have time? I've got time.
Thank you so much, Dr. Weil. Boy, what a foundation of knowledge is in this man right here. Again, thank you for coming and sharing some of that knowledge with us about soil health and cover crops. In a moment, we're going to take a quick break. I say quick break because it's going to be about 10 minutes, enough time to get a refill on coffee, maybe get rid of some coffee, get a cinnamon roll. But we want to ask, is there anyone that has a specific question? We have microphones out here. Just raise your hand, a specific question about cover crops, about soil health, about soil structure. Do we have any questions? Just raise your hand, please.
How much consideration did you have to give with your herbicide program on your crops when considering your cover crop species?
The question was about herbicides and cover crop species selection. You need to give a lot of consideration to that, depending on what you're using. I've had some very nasty effects of things like Callisto, for instance, that has long-term effects, and then you go fly on something like a brassica, and it'll wipe it out. So you do need to, that's one of those things, you can't just throw the cover crop on and do everything else like you've been doing. You need to think about that. Again, it depends on whether you're going to be planting it after harvest in fall. That's a longer time. But if you're going to be, for instance, drilling it in June, then you have to be very careful. Yeah.
The question here.
When you plant cover crop in May or June, when the corn's 10 inches tall, and then you run over it with heavy equipment in the fall, after you get your corn off, spreading manure and running over it with silage wagons and choppers, does that cover crop continue to take the winter and come on up to spring to mount to something?
So the question was if we plant a cover crop, so if you're thinking of that drilling early with skip row. Yeah, we ran harvesters over that. Of course, that's not every row, but it takes that. They're pretty young and flexible at that when they get run over, and they come back up. We didn't have any. In fact, sometimes actually, I'm thinking about it now, sometimes the combine wheel tracks did better when it was dry, sandy soil, because that packed it down a little bit and had better moisture. So, I don't have experience with manure, spreading manure. Again, that's pretty heavy equipment. That's going to leave some tracks, yeah.
Any other question? Have time for one more question?
Yes, sir. I was wondering about the effect of soil structure from brassicas, specifically turnips, and how that can change your top layers, and is it advantageous?
So that question was about how the brassicas affect soil structure. So one thing that we actually spent a fair amount of time doing research on, that's where you probably heard the name tillage radish. Steve Groff's a farmer and no-till advocate up in Pennsylvania. He came up with that name. I was working with him using brassicas to alleviate compaction. And the way they do that is by bio-drilling. So that brassica root, not the big fat part, but the thinner part, is able to push through very compacted soil during the fall and winter when the soil is pretty wet and soft. And then those channels stay there, and then your crop the next summer will be able to follow those down. So we've It's hard to measure a change in bulk density, the way you usually measure compaction, but you're alleviating the effect of compaction. And corn and soybean roots, even several years later, will follow those paths down. So that's how that affects the compaction. Now, aggregation is a different story, and that has more to do with root exudates and microbes pulling those particles together and binding them together. But the brassicas are actually pretty good at both. You end up with a very friable soil. If you've ever had a stand of brassicas, you realize that the soil becomes very friable and well aggregated.
Very good information. Thank you for the questions, and thank you again.
All right, appreciate it. Take care.